I'm Anil Kumar sharing with you a test problem on application of exponential functions. Question is, a population of yeast cells can double in 2 hours. Assume an initial population of 120 cells. What is the growth rate in the percent per hour of this colony of yeast cells? Part B is, what will be the yeast population after 210 minutes? And C is, approximately how many hours will it take the population to reach 500,000 cells? I'd like you to pause the video, answer this question, and then look into my suggestions. Well, this is an excellent question and it has all the components which you should know in solving application questions on exponential functions, especially growth. Now, the first statement here is population of yeast cell can double in 2 hours. That means doubling time D is equals to 2 hours. Now it says assume an initial population of 120 cells. So let us say P0 is the initial population and it is 120 cells. Now we need to find the growth rate. So let growth rate be R in percent. So we'll let us say it is R percent. Growth rate is R percent, which we need to find. Okay. So we are going to give growth rate in percent per hour of this colony, right? So what is the formula which relates all this? So we know that population at any time t can be given as initial population times 1 plus, right? So growth rate has to be added to it. R percent means R over 100, right? R over 100, that is R percent. Exponent is time t, correct? So from here we can find the growth rate. Now since we are given that the doubling time is 2 hours, it means if you start with a population of 120, so let me write 120 for the initial population, right? Then it doubles, that means it becomes 2 times 120 in how much time? In 2 hours. So that is what we are given, 1 plus R over 100, and T is 2. So let's substitute all this. T here is the doubling time, since I have taken final amount or final number of cells as twice 120. So that is how you get your equation to find the growth rate. I hope that's absolutely clear. Now you divide by 120, so what do you get? You get 2 equals to 1 plus R over 100 whole square. Perfect. Now you need to square root, right? So whenever you square root, you have to take a positive value in this case, since the numbers or the growth rates are all positive, right? So when you do square root, let me now take it to the right side since I may run out of space. Okay. So what I will do here is, I will write this as equal to square root of 2 equals to 1 plus R over 100. Is it okay? Now we'll take away 1 and multiply by 100 to get R, right? So we'll write R equals to square root of 2 minus 1 times 100. So let's use calculator to find this value. So we have square root of 2 minus 1 equals to, and then we'll multiply this by 100. 41.42%. So that is what we get, R as equal to 41.42%. Let me squeeze it in here. So that is the growth rate which we get for the yeast cells in this particular case. Okay, so that is our answer. So growth rate is, you can say 41%, approximately 41% or 41.4%. Now second part of this question is, what will be the yeast population after 210 minutes? Now once you have found the growth rate, you can substitute the value of r here, you know r over 100, right? And then find the population. But what I will do this time is I'll use a different formula just to give you, different ways of looking into the same thing. So that will give you a better understanding of how to solve such a question. So now what we will do is we'll use the formula which we can use with doubling rate, right? So we can say that the population P at any time T is given by initial population. In our case it is 120. Doubling time we are given, so 2 is our factor by which it doubles every t over doubling time, and doubling time is 2, so t over 2. Do you see that? We could use this formula and then also find the value. Now t is given to us as 210 minutes. You need to convert that time to hours. So we'll say t equals to 210 divided by 60 hours, correct? So let's use calculator, find this out. So we have 210 divided by 60 equals to 3.5. Now from here we can calculate. This is 120 times 2 to the power of 3.5 divided by 2, right? Since t is 3.5. So let's use calculator, find this answer. So what we are looking for is 120 within brackets 2 to the power of within brackets 3.5 divided by 2 bracket close equal to. So we have 403.6. So 403.6 means 403, right? So number of each cells after 3.5 hours will be more than double, right? 403 cells, right? That is what we are going to get. Now the third part is approximately how many hours will it take the population to reach 500,000, right? So that means in the last formula we used, this formula, we'll use this formula. 500,000 is our number of cells expected. So we'll write 500,000 here equals to 120 is the starting point. 2, we are using doubling time formula. T over doubling time is 2. We need to find this t. That is how we are going to use it, right? Let me write down doubling formula here once again. General formula for doubling could be population at any instance of time equals to initial population times doubling time, t over doubling time, right? 2 is because it doubles and d is doubling time. So that is the general formula which we have applied in second case, and we are continuing with that formula. So to find time, what should we do? We'll divide by 120, correct? So let us solve it. So that means, that implies 500,000 divided by 120 equals to 2 to the power of t over 2, correct? Now to solve for this, we can take log both sides. Let me first divide, or we'll divide it later, doesn't matter. To solve for this, we have to take log both sides. So that is a good way of finding time. In fact, that's the only way, otherwise you can estimate. So we take log, we get log of 500,000 divided by 120. We'll simplify everything together, equals to t over 2. When you take log, t over 2 comes here, and then you get log of 2. So these are the properties of log which we are using, correct? So you can now simplify this. You can find this log divided by log of 2, multiply by 2 to get t, okay? So what we get here is t equals to, so we have to multiply by 2 times log of all this, 500,000 divided by 120, and this comes in the denominator, correct, over log of 2. Let's use the calculator, find this answer. Okay, so we will do first this part and then slowly we'll do everything. 500, 3,000 divided by 120, bracket close, equals to, then we'll divide by log of 2, divide by log of 2 equals to, then we'll multiply by 2. And we get what? 24.05. So it's 04. Okay. So that means 24 hours, right? So we get time as equals to 24 hours. Do you see that? So approximately how many hours will it take the population to reach 500,000 from 120 cells? The answer is 24 hours, correct? So you get 24 hours here. So that is how you can solve this question. I'd like you to go through this question once again, understand how to find each particular thing in this case and how to use two different formulas for the same thing. Well, you could have used this formula itself and continued. But whenever doubling time or half time is concerned, this is a better formula to apply. It gives you more accurate results. I hope that helps. Thank you and all the best.